Good afternoon, ladies and gentlemen, and welcome to Data Champions Online Financial Services. My name is James Bowater, and I am one of the production directors here at Corinium, and I'm delighted to welcome you today. For those of you who have joined an in-person or online Corinium event before, welcome back. For those of you who are joining for the first time, welcome, thank you, and we hope that this will be the first of many of our events that you attend. Before we jump in today's fantastic content, I wanted to take just a moment for a couple of housekeeping announcements. Firstly, through the entire event, each session has time allocated for our expert speakers to answer your questions. So use the Q&A module below, and please do submit your most pressing questions throughout the session. And at the end, we'll do our best to answer as many as possible. Across the 3 days, we do have some live polls as well during the sessions, so make sure that you take the opportunity to get involved there, cast your vote, and express your opinion. Give us an idea of where you are in your journey. In the unlikely event that you do encounter any technical issues during the event, please firstly refresh your browser and re-log into the system. That should fix the majority of problems. If it doesn't work, then just drop the team a message in the Q&A module and we'll give you some one-to-one support. On your screens, you'll also notice an array of downloadable content, including our global online and in-person events calendars. So please do take the time to download some resources from there and take those items away and read them in your own time. Now, of course, during the sessions of this event, you get to see the faces of all of our speakers, and we would love to see you. We'd love to see who's taking part and watching us. So I'd encourage you to take your phone out, flip it round, take a selfie, and post it to LinkedIn using the hashtag Data Champions Online and tag us at Corinium Global Intelligence. Just to encourage you all not to be shy, one person who shares a selfie will win a pair of AirPods, with the winner being revealed on Thursday. So do make sure you get your selfies in before then. Now, with the housekeeping out of the way, it's my pleasure to introduce our first speaker of the week. That is Matt McCow. Matt has worked in a variety of roles at some of the biggest tech companies in the world across many industries for the past 20 years. Over the last 8 years, Matt has focused on helping enterprise organizations define and implement their enterprise-wide initiatives for AI, big data, and analytics. Matt is currently Global Field CTO for HPE, and in that role, Matt works closely with executives at enterprise companies to develop their roadmap and strategies for data-driven digital transformation. In particular today, Matt is going to be talking about the industrialization of AI and ML technologies. So as I said, please do send in your questions throughout Matt's presentation. And with no further ado, I'll step aside and hand things over to Matt.
Thank you, James. Hello, everybody. It was quite the intro. A lot of buzzwords there. Hopefully, we'll distill what some of those buzzwords means. It's a little awkward doing this virtually. Normally, we're at a conference, we're networking after, so I am standing. So if I look like I'm fidgeting, well, it's because I am fidgeting a little bit. I'm standing up to try and emulate what it would be like to be at a real conference. So at a real conference, you guys are going to raise your hands, ask some questions. So please submit your questions in the Q&A. We'll get to them after this presentation, but I want this to be as interactive as possible. So anything that you think of that as I'm giving the presentation, please feel free to ask those questions, and we have plenty of time at the end to get to them. So industrialization. Well, what's industrialization all about? What are we really talking about when we discuss industrialization? Well, when we discuss industrialization, what we really mean, or what we really are thinking about, is sort of a factory model. And a factory model, why do we need a factory model? Well, we need a factory model because many organizations are looking at things in terms of the applications that serve their clients. Your customers, your clients, applications are ruling the day. And many organizations have become application-centric. As you have been doing digital transformation, you've been focusing on those applications, and those applications have been producing data. Maybe even some of those more sophisticated applications are consuming data. And so what we want to talk about, what we need to think about from an industrial perspective to really get to scale is to marry applications and data together. And so again, as organizations have been doing this digital transformation, they've largely focused on the application estate, but have sort of left data behind. And now as data, as AI as a buzzword, and machine learning, deep learning really become more prevalent, organizations are starting to look towards those technologies to try and get towards that data-driven organization. But we need to look at the math. So let's take a look at the math that's driving this approach, the process, and some of these problems. And the first is that, as I sort of mentioned, analytical demand is growing. It's in many organizations, the demand is growing exponentially. But what we then see is that the data volume is also going exponentially. You might even say it's going through the roof in many organizations. The amount of data being created from applications, IoT devices, big data systems is oftentimes more than organizations can handle. So they are hiring analytics teams. They are taking that data analytics discipline and design and have created this thing that we call data science. And we are hiring data scientists. But this arrow is a little different because organizations want to hire as many data scientists as they possibly can, but they're struggling to either hire the right talent or, more importantly, retain the right talent, which makes things even more challenging. Couple all of that, especially with the current economic conditions, we have at best level IT budgets, but in many cases declining IT budgets. So we have all this demand from the business, more data than we can possibly account for, potentially this new type of resource coming on the scene, and budgets are flat to declining. So how do we deal with that? Well, industrialization is the answer to that approach. So why industrialization? What is industrialization all about? Well, think of the analogy of a factory. In a factory, let's use an automobile as an example. In a factory producing automobiles, you generally have many things that are occurring at the same time. You have the design team that is actually not thinking about the model that's on the line today, but they're thinking about the next model 3 years, 5 years, 8 years out, right? They test that at auto shows and that sort of thing. But the auto that's being produced at the current place in time needs to make sure that we have the right supply chain set up. We need to make sure that we have the right machines and tooling in place to be able to build that. And we need to have the right workers with the right skills in place in order to actually build that just in time. And many organizations are now starting to look at analytics and data science in a similar way. And the idea here is that we want as much automation as possible. We want to drive out as much waste in this process with lean thinking, and then get towards a continual improvement as we do this process of data science. So that all sounds good, right? Well, as we know, there's most likely going to be things that get in the way. So let's talk about some of those challenges or things that are inhibiting organizations from getting to that industrialized process. And the first is as it relates to the organization. Data science is a team sport. Data science is more than just those data scientists that we were talking about on that previous slide. And we're going to talk about data scientists and some of these other personas in more depth as we go forward. But in many organizations, especially large organizations, the people that are operating on data science, working on this process of industrialization or operationalization of those data science models, come from many different departments. We have data governance, data quality, data engineering teams, we have software engineering teams, we have operations teams. All of these people are involved in this industrialization process, and they are oftentimes not part of the same organization. And as we know, in large organizations, org structure and silos tend to break down the efficiency of any work that we're trying to do. Next, these organizations are oftentimes dealing with technical debt or legacy tools and applications that don't allow for an efficient process. And so many organizations that are coming out of the data warehouse world are looking to modernize those systems. But even the more modern systems like data lakes are somewhat antiquated now and are not scaling well to this industrialized, repeatable process. There's a tremendous amount of waste in that process. Plus, we have rigid infrastructure. We have outdated tools for doing some of that modeling. And then the runtime environments are oftentimes very different. So we have this legacy estate, which means we're doing things very ad hoc in nature. And ad hoc means we put everything we've got into building this model one time and getting it put into production. But what if we have to do it again and again? Going back to that graph about analytic demand increasing exponentially, we can't do ad hoc anymore. And then lastly, we need to think about how organizations have outdated processes. These processes are generally not automated. They're generally very reactionary if they exist at all. And so an example would be, let's say that we've bought some sort of AI tooling to sit on our factory floor that measures defects. So it's hooked to a camera or a video system, and it's looking for defects in the manufacturing process. Well, if we don't have good processes to deal with defects as they arise, we have to stop that assembly line, or worse, we have to go all the way back to the beginning to restart it. So we need to make sure that our organizational processes are able to adapt to any issues that we find. Whatever the outcome of that analytical model is, the organization needs to surround that analytical model to ensure that the business processes are efficient enough in nature to take advantage of the brilliant data science that's going on. And in lots of organizations, the point of view, the way you look at these issues is going to depend on the persona or the individual looking at these problems, right? And so the line of business in many cases is looking at things by saying, I just want analytical outcomes. I want to drive more efficiency. I want to reduce costs. I want to retain my customers. I need to reduce fraud. You can Google the use cases per industry. Because we're talking about financial services today, there is no shortage of use cases for analytics. Financial services organizations have tremendous amounts of data, both from the traditional banking and investment systems, as well as in your customer and client base. And so the business is demanding answers. It's demanding value from this. We have data scientists that say, just give me access to data. You tell me what the problem is, give me some data, I'll figure it out. Whereas we've got teams of people in the software development organization saying, all right, data scientists, you just hand that model to me. I'm going to build a series of APIs that I'm going to implement or integrate these into my various applications. Operations team just wants to know, hey, what are the uptime requirements for this solution? How much gear do we need? Where does the gear need to run? What's the DR strategy for this solution? My data engineering team is just saying, hey, listen, I'm going to take all this data, I'm going to merge it together, I'm going to make sure that it's available to you, but what happens after that is not my problem. And then lastly, we have a security organization. And if you have had any interaction with security departments, or maybe you on this session are part of security, your answer and your approach to this is, yeah, all that sounds really well and good, but we have certain standards that we must adhere to. So you want to give access to data scientists, access to production data? Okay, well, it depends. The answer is, it's going to depend on who you are, what authorization you have, what the data looks like. And doing this repeatedly, getting automated access to data, yeah, I'm not so sure about that. So you've got all of these different people with different points of view on how data analytics should work. But in reality, they all need to be working in harmony. They have to be working together to try and solve this problem. And so the next question we're probably asking ourselves, and the next question you may be rhetorically asking me or on your chat window is, Matt, okay, so those are the problems, those are the personas. What does good look like? How are best-of-breed organizations solving this? And you may be working for one of those best-of-breed organizations. Oftentimes, outside of the Silicon Valley, FANG companies, financial services tend to lead the way in terms of innovating new solutions, adopting new technologies, and building and deploying them out to scale. And so this approach and this set of opinions about what good looks like, it comes from my perspective and my team's perspective, dealing with best-in-class or world-class organizations, many of them in financial services, who are doing this at scale. They figured out the industrialization process. And it starts with an R&D lab. Now, you're probably thinking to yourself, why do we need an R&D lab? Well, the R&D lab, just like you would have an R&D lab when you're building an auto, right? So you need to think about what you're going to build next, what the new tooling requirements are to build that auto. Maybe there's a new manufacturing technique in place. What is the supply chain going to look like? How do we get those supplies just in time to those skills? And so to translate that analogy to data science, we need an R&D team to figure out what the latest and greatest tools and libraries are out there. Do we deploy this using Kubernetes? Does the production team know how to use Kubernetes? Do they require Kubernetes? How do we integrate this with the CI/CD process as part of that? Is IT ready for these changes? Is there a certification process that we're going to have to go through with these new tools and libraries The R&D team is solving all of those sort of big picture down the line problems well in advance, so that the data scientists, the teams out there actually building and training those models, can get access to the right tools at the right time, that there's a supply chain of data available to them when they need it, and so that when they are ready to have that model deployed, the production team, the I team, the operations team, it doesn't make them wait to certify those tools. That as this model goes through this factory process of getting put into production, that the production environment is actually ready and waiting for that model, and we don't have to push pause. And a lot of this involves agile techniques, but it can be done in more traditional techniques as well, but it requires a lot of open communication and strategic planning, and that's what that R&D team's all about. But getting back to our data scientists, again, fundamentally are here to build and train models. They're answering very broad questions. They're doing exploratory analytics. They're just like normal scientists are. In the image that always comes to mind for me is this mad chemist. Maybe they shouldn't be mad, but this mad chemist in a lab mixing chemicals, and they blow up and their hair is all crazy. Well, a data scientist does a lot of experimentation, and sometimes those experiments fail, or sometimes they write code that crashes the underlying system. And so data scientists are a different breed of developer. The way they do developments, the way they interact with the systems and the tools and the data is very different than a traditional software developer, and so they need to be treated as such. They need to have isolated environments, isolated both from one another as well as from some of these enterprise systems, but still given access to that enterprise data. So they can build their models, they can do A/B testing against production data, spin things up and spin things down. That is an operational best practice. And organizations that don't give data scientists the freedom to self-serve around these capabilities are not going to get to that industrial scale. Another big part of this is integrating with the enterprise code registries, repositories, etc. The modern lingo we're using in this is GitOps. The integration into GitLab, GitHub, that drives the overall code migration, the code integration, and potentially the pushing of code automatically into a production environment if the organization has that level of sophistication. But at a bare minimum, these data scientists need to be checking not only their code into a code repository, but they need to be checking the broader set of metadata, or the data sets that were used to train the model, the associated libraries that are going to be used to actually execute that model, all need to be packaged up and checked in so that other data scientists that come down the line, and we'll talk a little bit about those other data scientists, don't have to start from scratch every single time. But I mentioned earlier that this is a team sport. And so the second actor, the second persona operating from this team perspective are the software engineering team. Now, in many organizations, you've got data scientists that sit nowhere near the software engineers. But in this space, we want the software engineers to be working very closely with those data scientists for a couple of reasons. One, the software engineers are going to help with the operationalization of that model. Remember, data scientists are very good at doing the quantitative analysis. They're very good at building models, and they're using notebooks that help them write some code, but they're not hardcore software developers in most cases. So what they need help with is wrapping the code that they write, the analytical models, so that that code actually executes in production. So that's where software engineering comes into play. Software engineering wraps that code and makes it deployable. And so here's another sort of example in terms of that manufacturing. So let's say the data scientist has built a predictive model that based on certain factors will predict when there's likely to be a defect on that manufacturing line. Now, that model gets developed in Python. There's a series of libraries that are used to help create the linear regression, or whatever the k-means clustering may be. But production, that camera that I was talking about that has the video feed, that's looking at the line, trying to predict defects, runs C++. Well, someone has got to take that Python code and either wrap it up in an application or create an endpoint so that it can actually be executed in that endpoint at the edge running C++. And so that's where the software engineering team comes into play. They need to work closely with those data scientists to make sure that that code is either rewritten, refactored, or wrapped so that it can actually execute down the line. And we need to make sure these two teams, or these two personas, are working closely at the start of the process, so that we're not waiting for that code to get checked in or tossed over the wall to then be refactored or optimized for runtime. But the second thing that these software engineers are working on is helping to incorporate or integrate this data science way of looking at things, this code, these tools, these libraries, integrating them into that GitOps process, as well as tying into the broader DevOps processes, including the CI/CD pipeline. So what does CI/CD stand for? CI stands for continuous integration. The common tool set that you see that's been around for quite some time is Jenkins. Jenkins is going to detect when code has been checked into a source code repository like Git, and it's going to say, ooh, I get to go try and compile this code, and I get to test it to make sure that it works. So that's what continuous integration is about. It's about running the test cases to make sure that the code and the overall application space will actually pass tests and will be able to run in production. That's where then CD comes into place. CD stands for continuous delivery, which is the packaging of that code and the associated libraries and the other applications, creating a container. Most organizations are using containers to deploy these. So packaging all of that up into containers and then making that container deployable into production. So that means adding enterprise logging, security, and monitoring so that that container, once it is running, conforms to enterprise standards. And so that's the first part of continuous delivery, is the packaging and making that ready. The second part is continuous deployment. And best-of-breed organizations have all of this automated. Every potential piece of code that's checked in is deployable. So that implies that you need to have really, really good tests and really, really good packaging so that we can now push that code into some sort of production. Now, many organizations don't have automated deployment into production, but as we see more modern tools, as Kubernetes becomes more common in the runtime environment, we're seeing organizations use tools like Kubernetes or frameworks like Kubernetes to deploy those containers in a multi-tenant production or runtime environment. And in that environment, we have the next set of personas, our operations team. And our operations team makes up a key part of the DevOps process. They're the ops side of it. Software engineers are the devs. Ops is ops, obviously. And the ops team is responsible for managing this environment and ensuring that it's set up to scale properly or potentially auto scale as there's more load put on the system or load is wound down, that we're appropriately using the underlying resources, whether it's an on-premises set of infrastructure or we're deploying in the public cloud. We need an operations team to monitor the runtime of that environment and all the other environments. Make sure jobs are shut down so we don't have outrageous bills from the public cloud. This ops team is a key part of this overall process. Well, the next group of people that come into play, the next set of personas, is our data analytics team. This is our more traditional enterprise reporting function. And sometimes they sit alongside the data scientists. Sometimes they're a separate function. It totally depends on your organization and your enterprise. But the data analytics team is responsible for managing the runtime environment, but not the environment itself, but rather the model, the efficacy of the model, making sure that the model is executing so that they can create enterprise dashboards and reports on how that model is executing. How many defects did we have today? Are we reducing defects over time? Are they increasing? Are we able to run reports around the overall enterprise function of this analytics? And how does that compare to everything else that we see? And this team is really, really important for doing this. We don't want to just set and forget or push and forget our model into production. We need to monitor it because oftentimes models over time will decay. They will decay because environment variables will change. Maybe the supplier for paint on the manufacturing line for the auto changed, or maybe the underlying steel that was used in the building of that model frame, the supplier changed. And so we're starting to see more defects, or we're seeing fewer defects. The important thing is to track these issues so that, and then report on these and potentially then notify the data science team that, hey, there's something wrong here. The model's no longer as effective. We're not seeing as many defects, or we're seeing more defects. Is there something wrong with the model? And the data science team is going to say, I don't know, let's go check it out. And so that's why it's really important to have this process integrated with the overall GitOps process. Because rather than starting over fresh, remember we talked about potentially finding a defect. We don't want to bring that car all the way back to the start of the manufacturing process. We want to stop the line or potentially monitor what's going on with the line, pause, adjust or adapt, and then continue that manufacturing process. And so in the case of data science and analytics, the idea here is that we want to retrain that model. But that's only really effective if we can rehydrate that environment. So we need to be able to check the code out. We need to be able to check the libraries out that the code was assembled with. We need all of the data that was used to initially train and deploy that model, and actually use that data as the starting point for when we go and retrain it. So we need to hook into the enterprise data repositories. We need to re-attribute this model, adding in new variables, retrain it against different data sets, check it back in, and ultimately redeploy that model again. And this is how we get to a virtuous life cycle of analytics. This is what good looks like in terms of operationalization. And similar to that factory model, we are following an industrialized process. We have a factory line. We have best practices and tooling in place so those data scientists can get to work very quickly. They're getting access to enterprise data when they need it in a way that meets the security requirements of the organization. They're working alongside other users that are also developing code that will wrap or encapsulate or ensure that that model can actually be deployed. We're integrating against testing systems and QA systems to ensure that we can continuously integrate that code and then ultimately get to a deployment. So that's what good looks like. It's this virtuous life cycle that very much mimics an industrial process. And so getting back to those three key challenges I talked about earlier, the first thing is that we need to harmonize the disciplines in the organization. We talked about a number of these personas, and there's lots of personas that sit out just outside just these four different personas that I talked about. We have data governance, we have data stewards, we have lots of other organizations. And the important thing is not necessarily to realign our organizational structures, but to harmonize these various disciplines towards a common outcome. Bring these teams together and work collaboratively on this analytics and data science process so that we can smooth or reduce the friction as we think about industrialization. The second thing is we need to modernize the technology environment. That doesn't necessarily mean just rushing to the cloud. We need to modernize the underlying data platforms. We need to modernize the underlying infrastructure. We need to provide new infrastructure, such as GPUs to those data science teams so that their models can be trained and executed far more quickly. And we need to allow a self-service model for these data scientists to be able to spin up isolated sandbox environments, isolated training environments where they get access to that shared production data in a secure and compliant way. And then lastly, we need to make sure that we have modernized the enterprise change, the business processes that are going to respond to these. Again, just because we can predict something is likely to happen using advanced analytics and data science doesn't mean the organization can react to that. And so being able to change the organizational processes, or at least adapt the organizational processes. This is oftentimes the hardest part of the whole process, but it's also the most important. Because again, just because we can predict something or even detect something, if we can't act on it in a timely manner, then it's all for naught. So in conclusion, I want to leave you with just a few key points. Getting back to that first one, data science is a team sport. All of these different personas need to be acting together. But in order to scale data science to deliver that business value, everyone has to think a little differently. And that means changing those organizational processes. And they're not going to be successful without the right tools and infrastructure and environments and self-service capabilities that are frankly kind of scary to IT teams and security teams. The ability to self-serve environments and connect to production data is a scary thing to think about. And so that's why we need to have the right modern systems in place to allow for that, meeting the enterprise governance and security requirements. But as I said, that organizational change, that's the hardest part. Getting the business to be thinking from an analytics perspective, designing applications from an analytics perspective, and actually reacting or designing the way the business operates from an analytics perspective, being more than just data-driven, but actually being analytical-driven, that's the hardest part. That organizational change. But best of breed organizations that have figured out that industrialization have also figured that part out as well. So that's it for me for this presentation. We now have plenty of time for Q&A. So first of all, there's my email address. If you want to shoot me an email, if you want to do some follow-up offline, shoot me an email. connect with me on LinkedIn. A colleague of mine, a gentleman named Doug Packett, has written a series of blogs on this topic. So please connect with me, and let's get to some of these questions. So James, what are people asking?
Yeah, absolutely, Matt. And just a reminder, if you have a question that you would like to put to Matt, just click on the Q&A module. You can put that in there, and we'll get through as many as we can. So the first one I can see is someone saying, great points. Can you touch a little upon data science code standardization best practices that the industrialization model should follow?
So code standardization, yeah, that's an interesting one. So I would say that, well, I guess it's just going to depend on the size of your organization. In terms of best practices there, this is something that the R&D lab or that center of excellence, if your organization has that concept of center of excellence, that's where these sorts of standards are going to be defined. But in terms of how you want to standardize, well, you need to sort of think like a software developer. And I know that's a little difficult because data scientists are oftentimes not classically trained like software developers. And so that means taking a lot of the repeatable code or the plumbing type code where you have doing sorts or doing particular sort of manual processes like regular expressions, and building those or bundling those into, depending on your programming language, into functions or methods or classes to get neater and tidier code. So that's one of the first things. You don't want these Jupyter notebooks with hundreds and hundreds of lines of code when you have repeatable functions that you should be packaging up in terms of methods, functions, or classes, depending on your programming language, and then checking those in so that others can use them. You know, thinking like a software developer, where you import classes into your notebook or your IDE ahead of time, and then using those functions in an object-oriented programming perspective. But that's tough, right? If you're not a classically trained software developer, you're good at Python and scripting, then you may need to pair up with a software developer. So again, harmonizing those disciplines is really, really important, not just in terms of building the work product that gets tossed out into production, but actually getting some of those software development best practices is a really good way to enhance the team. Really good question there. What's next, James? What else have we got?
Yeah, absolutely. So let's have a look. The next question, we're going to go, why do you struggle with the process of industrialization? And I suppose a follow-up to that from me, how can they overcome those common issues?
Yeah, so I would say that the biggest barriers are they're process-based, they're organizational-based. Those are really, really hard to break down. That requires an initiative from leadership. And so as practitioners, there's not much we can do. But if you are a leader in one of those positions, if you're senior in your department or you're an executive, getting your organization to think differently and harmonizing those disciplines is the most key. But let's actually back up. Let's get back to some of those things that also get in the way from a technology perspective or a data science perspective. That first is that gap between the tools, libraries, applications, frameworks, workbenches, whatever you want to call it, that is used to develop the model on the front end. That being way out of whack with the runtime environment on the back end. And even if we're talking about something as simple as the analytical model will run in the production Hadoop data lake. Most organizations are still running Hadoop today, and that's where most analytical models are also executing, at least from either a batch or a runtime perspective. But runtime or production from a data lake perspective, or whatever the environment, is oftentimes a very fixed and brittle environment. And by that I mean it gets updated once a quarter, once, maybe twice a year. And so that means that as a data scientist, you can't be too out ahead of the software definition of runtime. So let me give you an example. Let's say that you have trained your model using the latest version of Spark. Or Spark is the execution framework that model was trained on. And you say, so I've optimized for the latest version of Spark, which takes these two open source libraries to execute. You package that up. But production is two versions of Spark behind, because that's what IT was able to certify. That's what the other applications depend upon, which means your analytical model is not going to execute until runtime catches up to that. And so we've got two choices. One, we get that R&D lab process set up. So way ahead of time, we're working to make sure that prod is going to look like development. But if we can't control that, then that means we need to be realists. That means we probably can't use the latest models that are out there. Until production can catch up, that means we need to have our model trained using what prod looks like. And I know it's hard to accept that. As data scientists, we want the latest and greatest of everything because there's new techniques being checked into the public repos every day. There's really good software out there. But IT, remember that first IT graph was kind of like, like that? Not necessarily able to keep up. So the trick here, and this is what crushes most organizations, and this is what upsets most data scientists, other than all the data wrangling stuff that you have to deal with, is that expectations and being out of sync between dev and prod. Nothing frustrates a data scientist more than spending weeks or months on a model only to see it not get deployed. So I would say that's probably the number one. There's a bunch of anti-patterns we can talk about, but I'd say that's probably the number one, is being out of sync between dev and prod. So what else, James? I hope that answered the question, by the way. If it didn't, shoot me an email. We can take it offline. Happy to go into that topic more.
Yeah, absolutely. I thought that was a great answer. But if you do want to pick it up, absolutely reach out to Matt, LinkedIn, email. So the next question I have here is, if there is so much legacy technology / IT getting in the way, shouldn't we just go straight to the public cloud? Perhaps we should. But the question is, what are you going to do in the public cloud? And then after you've done what you plan to do in the public cloud, then what? So let's use a practical example. So let's say that all of my enterprise data is sitting in a kind of an old clunky cloud era data lake. So it's sitting out there. But I need to do model development, and I need to get it done quickly because it's going to take 2 weeks after I get the ticket open to get an environment provision. It's going to take another 6 months for me to get access to that data, and I have to go through that process every time. So let me just go into the public cloud. It's got APIs, it's got GPUs, whether it's general purpose GPUs or TensorFlow processing units. It's got the latest and greatest versions of TensorFlow or PyTorch or Cafe2 or whatever the framework I like. That's awesome. That means I can go through my software development process really, really fast. And so I'm going to accelerate that software development process, which is a good thing. But that's just that first step. Most data scientists spend their time wrangling data and actually training their model against data, refactoring the model, training again. It's a very iterative process. And so just because you've torn down the barriers from that infrastructure provisioning process doesn't mean the next steps in the process are going to be any faster. And so that means you're going to have to bring that model that you built or that code you built back on premises to actually train it against the enterprise data repositories. And so I think the best of both worlds is actually a blend, a hybrid approach, where while you're waiting for your model training environment to be set up by the IT teams, you can be off doing your development in that public cloud. But remember, you've got to keep your expectations in check, because if the library that you use in the public cloud, that version of PyTorch, is not allowable on premises, then you've got to refactor your model anyway. And so you've got to keep your expectations in sync and then try and work with your IT counterparts to help them get those versions of the models incorporated more quickly, and see if there's suggestions you can make around self-service. And the IT people, they know. I deal with IT people all the time. They want to provide better service, better agility, more self-service, but they oftentimes don't really understand the requirements of a data scientist. They don't quite understand that the nature of that development is a little different. And so I would say one of the ways to reduce that friction is to sit down with your IT brethren and explain what a day in a life for you looks like as a data scientist. Explain how you go through your development and how sometimes you do write bad code, and sometimes it will crash a system. And so you need to be able to, within that isolated environment, bring it down and bring it back up again. And so you have to build that level of trust with your IT brethren as well. So really good question there. Again, it's not an easy answer, right? Because there's realities around the IT systems and the enterprise governance. They're there for a reason. But getting at that level of understanding with the IT teams will probably help them better understand what you need as a data scientist, and they'll be able to be more reactive and potentially even get you quicker access to things and align to be more in sync with the libraries and frameworks that you want to use. Really good question. Yeah, absolutely. And I think this one's another really good one as well. What if my company already has a CI or CD process and pipeline for application development? Should I build a new one for data science?
Well, in most cases, the answer is no. There was probably a lot of work that went into that DevOps process. In fact, DevOps as a discipline has been around for a decade now, if that dates any of us on this web conference. And so as a discipline, it's relatively mature. Whether the CI/CD pipeline in your organization is mature or not, that's to be determined. But the idea that CI/CD pipelines are generally workload agnostic, right? They check to see if code has been checked in. They kick off test frameworks. They package things up. Those are all very generic. What comes as a unique part of that process is when we start talking about ML ops, is that the artifacts that feed into that CI/CD process and how it gets packaged and then ultimately spit out the other side is what's going to change. It's going to be workload dependent. And so I would guess that the very first time that CI/CD pipeline was developed for your organization, it was for one type of application or one type of workload. And then another software development team was added on, and so they had to change it. And another software development team was added on, and it had to be changed again. And so, again, in the spirit of partnership, harmonizing these disciplines, as a data scientist lead or as a practitioner, you need to seek out who is responsible for DevOps in your organization, who owns the CI/CD pipeline, and sit down with them. And again, explain the uniqueness of your workload. Explain that you do use Git and that you do write code, but it's not Java, and that you do bring in libraries, but they're not the same as what you have in your .NET environment. And that the way you package up the artifacts of your algorithm include other dependencies, and that the type of tests that you are going to run require actually the building up of a full production environment to validate that. And so their eyes will probably explode initially, but then they'll calm down and they'll say, okay, some of these things we have in common, but some of these things are very different. And so what do you prefer for a test harness? And as a data scientist, you're going to go, test harness? I don't know test harnesses. So that's why it's important to work alongside the software development team. If you have a very large organization, you probably have just a DevOps team that is responsible for the CI/CD pipeline, and sit down and talk about the uniqueness of your workload, and then have them tell you about how the pipeline tests code and ultimately packages it up. And I think just that conversation and get on a whiteboard and start drawing some stuff out, that will allow these parties to come together. But most importantly, you are now part of the enterprise software development and release process. You're not the redheaded stepchild that is sitting in the corner doing unique things that doesn't incorporate with anything else. It is at that point that you're truly going to get to a point of industrialization. You're going to get to that enterprise scale. So that was a really good question. Again, there's lots of nuances there again, but harmonizing those disciplines and leveraging what's already been done, that's an advantage of data science. Being a couple years behind from a maturity perspective, traditional software development, you can leverage the best practices that the organization has around DevOps and GitOps and operational processes, and just bring the uniqueness of this workload into those. Great question, though. Really good question.
Absolutely. I think we've got time for one more. So this one is, how does Kubernetes play in the what good looks like scenario that you described?
Yeah, so Kubernetes is, so for those of you who don't know, Kubernetes is a container orchestration framework. It's an open source container orchestration framework. The container wars are now over. There was lots of different standards out on the marketplace up until very recently, and Kubernetes is the one that ultimately won out. So Kubernetes is a way to abstract underlying infrastructure and deploy containers across that infrastructure in a more agile way. And so how Kubernetes comes into play here is in a couple different areas. One, these development environments that data scientists use are oftentimes manually configured and created, and it's up to the data scientists to create the containers for this software that then gets orchestrated or deployed at model training time. So data scientists hate a few things. They hate wrangling lots of data over and over, and they hate building their own containers. And so Kubernetes does some of the heavy lifting here. Some of the frameworks like Kubeflow help with that. But Kubernetes is now becoming the enterprise standard for the deployment of containers. And so why it's relevant for a data scientist is not on the upfront development training side of things, but on the runtime. Knowing that your model, the code that you write and you check in, is likely to be orchestrated using Kubernetes means that you need to sort of have that software developer hat on, thinking that, well, my data science workbench is deployed using kind of clunky software. that means that I'm going to have a really hard time getting that model ultimately deployed into production. So thinking about and deploying that technology in a more modern way and asking your IT teams and especially your software development teams if from a model development and training perspective you can leverage what has already been built using Kubernetes is going to increase your likelihood of getting that model deployed into operations or productions faster. So that's where Kubernetes comes into play. It's oftentimes not something that data scientists need to think about, but being aware that there's an orchestration framework out there will potentially make your process of development and ultimately deployment a lot easier.
Absolutely. Thank you, Matt, for a fascinating opening session to Data Champions Online Financial Services.
Thanks for having me.
And no, not at all. And I'm sure I speak for all the attendees when I say thank you as well. And thank you to the audience, especially those who submitted questions for Matt. There were some great ones there. And if we didn't get to yours, I know we unfortunately had some that we didn't get time to take. But as Matt says, he would love for you to reach out to him, connect with him, and you can ask him those questions directly in a personal forum.